everyone, this is Dongli. I am the head of the product in Kyligence and also PMC member and committer of Apache Kylin open source project. As we know, Ray as the fast and simple distributed computing engine is well adopted in each domain, especially in data and AI. And ML SQL is an open source SQL variant for big data and AI. Today, I will introduce how ML SQL simplifies big data and AI on Spark and Ray. So here is today's agenda. Firstly, I will introduce the background and the challenge we have in Spark and Ray combination. Secondly, I will give a live demo to show about the new solution with ML SQL. Then I will brief what we did in ML SQL and then the technical deep dive. When data scientists do machine learning and AI on big data, mostly they care about two things. The first one is about the language, which is a user interface to interact with the machine from data users. Usually, they like to use Python the most, and the ML SQL is positioned here. So with ML SQL, users can simply write the SQL statement to finish AI jobs on the big data instead of writing Python scripts. The second one is engine, the underlying system used to execute the job and compute the data in a distributed way. So for example, we want to leverage the Spark for big data loading and processing, then use the Ray for machine learning and the model training and prediction. During the machine learning task, we also want to use the TensorFlow or sklearn libraries. To fulfill this, we need the engine to be efficient enough, and inside that, the data can exchange between the data, the different clusters with less shuffling to ensure the efficiency. And from the open source community, we observed the Spark and Ray combination is one of the popular solutions at this era. To realize the Spark and Ray combination, Python is usually used as the language by the developers because both Spark and Ray provide the Python API to write scripts and program. On Spark, you can write the PySpark. On Ray, and the programming methodology is quite easy and friendly to Python developers. But many of you may have the following problems. The Python is not as well known as SQL. As an advanced programming language, the Python has been well adopted in the data scientist and engineer group, but it is less popular with business users and data analysts. And Python cannot use as payload protocol to build up the data as a service to serve applications quickly. Learning curve. For the fresh users, they need to learn the Python first, and then PySpark, and then Ray programming. And also they need to understand the advanced programming and the tuning methodology of the whole technical stack, and then start to work. This is not an easy job. And also its lack of data ACL. This architecture only provides the language and the framework with no security management, so which requires the developers to define the security logics in their scripts, which misses the point for establishing a single source of truth for security as a platform layer. And the fourth one is environment complexity. So if you already have a Spark cluster and a Ray cluster separately already, it is hard to leverage both resources and the operation practice. We can talk about it later, but at minimum, an intermediate storage layer is required between Spark and Ray for data exchange, which brings more complexity to the whole cluster. So we come to the solution with ML SQL. ML SQL is a SQL variant designed for big data and AI, whose author is William Zhu from China. As a SQL variant, it has two basic elements, the language and engine, which is distributed engine based on the Spark. Just like the Java world, Java is a language for coding, and the Java virtual machine, which is short for JVM, provides the compiler and the runtime to finally run the program, just like the engine of Java. For ML SQL, the language is based on the SQL, and it has built-in advanced functions and syntax for big data and AI jobs, such as train and predict statement. For example, you can just write train something from some data to train a machine learning model based on a dataset. More importantly, if simple SQL is not enough, you can still have the option to embed Python in SQL statements for complex processing. Especially, these Python scripts can easily run on Ray cluster. The second is the distributed engine based on Spark API. It has a rich ecosystem that can integrate with mainstream data platforms like Data Lake, Data Warehouse, and other storage engines, and has many built-in machine learning operators to serve data management, BI, and machine learning workloads. More importantly, we developed an efficient way to submit the task to Ray cluster from Spark, which is belonged to the distributed engine. ML SQL has a wide range of data users. For data scientists and engineers, they are easy to write ML SQL statements through a notebook GUI or just write in scripts. And with ML SQL, it is very easy to build applications on ML SQL engine for business users. And also ML SQL can do more to publish data service as an API. Okay, so if you are interested in these scenarios, you can visit the website of ML SQL to learn more. All of that are open source, and you can find the document and the source code on the website. Yeah. So talk is cheap. Let's do a live demo to demonstrate the capability of ML SQL. So let's imagine that if you are a data scientist and the IT administrator in your company ask your help to analyze the cost of the cloud platform. For example, why the cost of AWS in the company is so high, or is there any action we can take to save the cost, or can we predict the cost in the future? So here is the notebook application above ML SQL engine. We use it to show the capability of ML SQL. So firstly, we have uploaded the data file in CSV format to HDFS directory. Let's take a look at the directory. Here we have a syntax in ML SQL to run some HDFS command like this. And we can see the data file is listed in the result. And we will load the data as a table. We write a load statement to transfer the data into a table format, and then use the select statement to preview the data. You see, two simple SQLs can convert a CSV file into a table. They are quite easy. This table will describe all the transactions of billing from AWS, but it's almost mockup data. Okay, so in order to analyze the employee's perspective, we need to upload the employee data also. So this table describes the join date and the leave date to the company for each employee. Okay, but we will find there are many empty cells here. We need to fill with some default value. Okay, so now we can use some Python to process the data in ML SQL. So firstly, we will define some environment variables and configuration for Python, and then we can just write a normal Python script. That's your usual way. So here we define the input and output as a table of ML SQL. And also we can create a array context to submit the job into an existing array cluster. And finally, we get the result as a table here. You see, if you want to leverage array, this is very easy. If you want to use another array, you can just switch the IP and port in the array context. Okay, so then we will do some table cleaning with SQL because we want to ensure the data quality. So we can use some case one and some function to process the data. You can see all of this processing is based on SQL. So all of the workload is run on Spark cluster distributedly. You see, so we build the pipeline from Spark and Ray together. We can get the data from CSV into Spark RDD and then process that into Ray cluster and then get the output and pass to Spark again. So from user's perspective, all you see is SQL. Then we can also define a UDF. Here we use the Scala to define a function to see if a cloud resource is unreleased from an employee after he left the company. And this kind of resource should be deleted to save cost for sure. So when we define this UDF, we can call that in the SQL. And easily we can get the labels of such kind of resource in the result. It's very easy. Okay, but time is leaving. Let's move to the machine learning part. For example, if we want to predict the monthly cost based on the history transactions, now we make some array for the feature engineering, and then we can also combine all the features into one column, and then we can use a train statement here to train a linear regression model. You see, just like you write a SQL, it's very easy. And when we build the model, we can register it as a function, just like the UDF. Yeah. And also, after we prepared the data set to predict, we can use the function here, which is just like we registered just now. So we can just use the model we trained in the SQL to get the prediction result. It's very easy. Okay. And also we can use Ray to do the same prediction. So like we just showed just now, firstly we can prepare the Python environment, okay, and also we create a Ray context to connect with an existing cluster, and also we will collect the data from the from Spark and just write some normal Python scripts. Here we use the linear regression from sklearn library. Okay, and when we train the model, we can get the model in the binary format and save that into the context. Okay, and finally we can also save the model into the disk and also load that into the context. And finally, how can we consume that? You can just get the model from the Ray context and write the normal Python code to consume that. And finally, we can get the input and the output from the from the ML SQL context and interact with the tables in ML SQL. So you see, what you need to do is to write SQL, Python as you want, to focus on the data exploration and the data science. You don't need to take care about the data pipeline and the data exchange uh, behind that. Okay. Okay. So here is the demo. Let's go back to the slides. Okay. So as we saw in the demonstration, so ML SQL as a SQL variant is very easy to use and seamlessly connects SQL and Python for users. Especially in notebook, it's all about SQL. There is no need to learn any new programming skill, no PySpark here, and also big data can be processed on Spark and Ray in one context. And it is very powerful and performant. Based on the Python ecosystem, all of the Python libraries can be called in SQL, like TensorFlow, sklearn, and so on. Users can just write SQL to support regardless of whether it is a batch, streaming, or machine learning task. Besides, if you are using Apache Kylin or other analytical engines, what you want to do is just write ML SQL in notebook and let it send the orders to so many engines. And it's on the security part, ML SQL has the built-in data security engine at the language level without requiring some underlying storage engine or some more developer efforts. And you can also set up the customer desensitization to protect your data. And also extensible. ML SQL engine provides rich extensible API and SDK to develop the plugins like UDF, UDAF, just like we showed on the demo. Okay, and in the open source community, there are already some many plugins for you to use, and you are invited to contribute more if you want, if you are interested to join the community. Yeah. So let's come back to the Ray and the Spark combination. At present, we have seen two kinds of the implementation here. The first one is Ray on Spark. It is developed by the Spark community, which means the Spark behaviors like the resource manager to run Ray process. See the left picture? The Spark driver and Spark tutor will launch the Ray process to execute the Ray task. In this option, we found that that an HDFS or objective store is required to exchange the data between Spark process and the Ray process. So each piece of data needs to be saved to a disk, which is definitely slow and hurting the performance. The second one is Spark on Ray, also called Ray DP, which is maintained by the Ray community. This idea is to consider that Ray is essentially a distributed programming framework, which is a bit higher than Yarn and lower than Spark, and provide Python API to run the program distributedly. So we can run Spark on Ray just like the way we did on Spark on Yarn. So no matter which method you use, both of them have the challenges of resource isolation and the data exchange issue. About the resource isolation issue, because the Spark and Ray processes because the Spark and Ray process will run on the same hardware and on the same operation system, the environments nearly overlap. Therefore, for example, all the Python libraries should be installed on each Spark node. This might become a disaster for maintenance in the production environment, especially in cases where multiple Python versions and customization are required. This should be some disaster. Yeah. And what's more, both options need an intermediate storage to achieve the data exchange. But RayDB uses its own built-in object store, which can be more efficient to leverage memory. It should be faster. Yeah. And so ML provides a new way as a third option behind the ML language as the engine level. We built a fusion architecture to combine the Spark and Ray together. Let's look at the architecture diagram. Firstly, we run the ML engine nodes on Yarn or Kubernetes and so on. Because ML engine is implemented based on Spark, we will connect each Spark executors with the Ray to submit jobs and exchange data. So in this way, we will run the Spark job on a Spark cluster and run the Ray job on the Ray cluster. This like the two-way we just talked about previously, where both workloads must execute in one cluster, which is more friendly to the maintenance team, also the developers and users, because use the dedicated resource to do dedicated work should be the best practice. Okay, so let's look at each of the Spark executor. We will launch a Python daemon process and a Python worker process from the executor. The Java the Java process is where the Python worker has a built-in Ray client module, and it can talk to an existing Ray cluster and submit the job. So how does the data exchange happen? We can explain the deep dive later. Okay, so now let's discuss about why we do it like this. With its architecture, we can see these following advantages. So firstly, the resources are isolated. Both the Spark and Ray are running as independent applications in different machines and different clusters. You need now to install the Python libraries on Spark cluster, and both your existing Spark cluster and Ray cluster can be leveraged, which is more adaptable in the production practice. And more to the point, the environment is isolated. You can connect to any one of the multiple Ray clusters, like maybe the production and testing environment, even in different Python versions and different configurations, so without affect the Spark cluster and redevelop the scripts. Okay, and secondly, the intermediate storage is not necessary for data exchange. It is more performant and stable. We can talk about this later in the deep dive part. And pluggable. Actually, Ray is optional here. Users can run the Python scripts in the Python worker only, or just submit the job to any Ray cluster. Only if you provide the connection information of the Ray, just like the demo we showed. You just switch the connector string, the host and port. You can just submit the job to another Ray cluster. Okay, so it's very easy to learn. Users do not need to learn the PySpark or Ray programming. They just need to be able to write the SQL. And also some basic Python for some advanced scenarios are also are enough. So it's very easy to learn. Okay. So from here, let's talk about the technical deep dive. How does Spark send the data to Ray and then get back the result? We talked about the processes inside the Spark executors before. So each process can launch socket server to exchange data. And the data format we use is Apache Arrow, and a very efficient columnar format. Here I want to mention that you may find that there are both Java process and Python process here, and we need to launch the Python from Java and communicate between them. So in order to fulfill this, we developed a dependent library called PyJava, and it's also open source on GitHub. You can visit the repository to learn more about the design and the technical details. Next, let's take a look at the detail about how data exchange happens between Spark and Ray. Let's start from this diagram about the data flow. So firstly, we have a table in the form of a Spark RDD, and we want to process that on the RAY cluster. So we need to send the data by partition to the RAY cluster and get back the result RDD. At the beginning, we launched several read-once servers on the Spark executor, and the number of the socket servers is the same as the number of the partition of the RDD. Okay, so and the system will adjust the number of partitions based on the current resource situation automatically. Then the Spark cluster will send the address of these socket servers to the Python worker. At this time, the user they can obtain these server addresses through the PyJava API. Then the users can start the read task and freely decide how to pass in the rise how to pass the array task. Okay, so these server addresses will help the user to get the data from the tables in Spark. After the processing is completed, the system will automatically start some array actors in the array cluster. And also, each array actor will provide a socket server service to provide the data, the result data. Okay, and then it will send the addresses to the Spark cluster, so that the Spark cluster will build a new table RDD for the result. And the number of the partitions in the table is consistent with the number of actors in array. So in this way, the processed data can be obtained from the array. So as a result, we can see that we just use the socket server to exchange data from Spark to Ray, and also get the result from Ray to Spark. It is distributedly and partitioned. With this, we can avoid the data shuffling to improve the exchange efficiency. Okay. And also, here we talked about how to use the array for data processing, and also for the model training, it might be different because the model training does not require the process data separately, and maybe need to collect the data as some node. So in such case, maybe we can just need to start one array task to obtain the table data and then perform the model training. So after the training is completed, we will store the model on the HDFS and return that to Spark in a single value table, which means that the table of just one record and one field to contain the address of the model. Okay, and then you can also directly transfer the model to Spark in a binary format and then save that in the data lake. So at this time, it is directly transmitted back through the Ray client. Okay. So till now, we have finished today's presentation. So as I talked with William Zhu yesterday, he is the author of the ML SQL. ML SQL is expected to bridge the data and AI, he said, and also it become the industry standard of language interface. So if you are interested in that, please feel free to join the community and learn about more. Okay, so here's today's presentation. If you want to learn more, you can visit the website or just contact us. So thanks. So if you have any questions, please raise. We can have a Q&A. Thank you.